So today we're going to be talking about averages. So a lot of times when you hear the term average, like what do you think about when you hear the term average? So sometimes you might hear, oh, well, the average IQ on Earth is 100, or the average score in a class was, say, 96, the class average. But when we say average, what do we actually mean? So that's basically what this class is about. It's about averages. So, well, what do we mean when we say average? So there are three main kinds of averages. So we have one type of average, which is called mean, which is the sum of values divided by the number of values. Median, which is the middle value. Mode is the most common value. So what do we actually mean by this? So basically, if we have, say, this sort of list of numbers, five people weigh 35 kilograms, 45 kilograms, 55 kilograms, and then there's another person who weighs 55 kilograms, and there's one person who weighs 80 kilograms. So what is the average weight? Well, first of all, does anyone know like how you can calculate mean, first of all? So the sum of all of the values divided by the number of values. Does anyone know what the sum of the values would be? So, was I speaking too fast then? If you want me to repeat anything, you can tell me. Okay, well, with mean, what we do is we add up all of these numbers together. So, so we have 35 plus 45 plus 55 plus 55, because there's two people who weigh 55 kilograms, plus 80. So basically the point of average is to, so for example, if we have all of these different people, you want to find kind of, we want to sort of compress all this data into one piece of data so that we know kind of what's around the center, what's kind of normal, what's a normal kind of weight in this room. Or on a population level, if we have, say, everyone in America, what is what is the average American person gonna weigh? Or what is the average weight in America? Kind of what is considered normal weight? That is what is sort of measured by average. And with mean, what we do is we take the sum and we divide it by the number of values. So in this case, we have five values, right? Because there's five people and each person has one value of weight, or one weight, like in terms of kilograms. And that means that we divide this whole thing by 5. And if we divide this whole thing by 5, we first need to calculate what the sum is. What is 35 plus 45 plus 55 plus 55 plus 80? And what we get is, if we calculate that, we would get 270, right? 35 plus 45 plus 55 plus 55 plus 80 equals 270. And where we got that was by adding all of these weights together. So now that we have this 270 divided by 5, we can calculate that again, and 270 divided by 5 is equal to 54. So the average weight in terms of mean is 54 kilograms. And you can kind of see that kind of makes sense, right? You see, you have 35 kilograms, you have a 45 kilograms, and you have 255 and 180 kilogram person. So 54 is kind of in the middle of all of these values. Like if I weighed 54 kilograms and I went into this group of people, I wouldn't be too far off from sort of the normal person. It wouldn't be too far off. But there's also other ways to measure average, or sort of central tendency is what it's usually called, which is kind of what's in the middle. So with median, it just means the middle value. So if we have a bunch of weights and we line them up from least to greatest, which this is already lined up from least to greatest, then it's just the one right in the middle. So the easiest way to do this, like for example, if you have 5 people like this, it's really easy to see, but the easiest way to do this is to cross out one from each side and just move towards the center until you get to the very middle one. And the very middle one is the median. So what is the median here? Well, the median here is 55 kilograms because it is the one that is right in the middle. So if you think about it, what this means is that there's an equal number of people who weigh more than the 55 kilogram person and an equal number of people who weigh less than the 55 kilogram person. And that's basically what median is. So it's not just the normal average weight, but it's the average person's weight. That's sort of what it means. And mode just means the most common value. So because we have two 55 kilogram, let me just erase this. We have, we have two 55 kilogram people, then that means that the mode is in fact 55 kilograms because that is the most common weight. So for 35 kilograms, we only have one person who weighs 35 kilograms. We only have one person who weighs 45 kilograms, but we have two people who weigh 55, and we have one person who weighs 80 kilograms. So that means that since we have two people weighing 55 kilograms and all the other ones only have one, or the other weights only have one person, that means that the mode is also 55 kilograms. So does all of this make sense to you? We will do more practice with this, so if you want to try, you can do that as well. We will do that later. So does all of this make sense? Do you have any questions on any of this? So Joyce says that it makes sense. Okay. So, oh yeah, and just one last thing with median. So right now we're predicated on the fact, or we're basing it on the fact that there's only 5. So that we can cross out from each side like that. We can cross out and find the middle one. But what if there is no middle ones? Let's say we have 4 people and it's say 1, 2, 3, 4. Just measuring the median of these 4 numbers. Then instead of finding the middle one, because there isn't a middle one like this, we would just average the 2 middle ones. So we would find the mean of these two, or the number that's right in between. So in this case, it would be 2.5, right? Because 2.5 is right in between 2 and 3. And you can also find it using the mean, because 2 plus 3 divided by 2, which is the number of values in this 2 range, is also 2.5, because it's 5 divided by 2. That says 2.5. Okay, so that is just a little bit of clarification on median. All right. So another way to think about it, let me just erase. Another way to think about it is in terms of colors. So when we have a color like this, we have 5 different colors, right? And these colors are kind of arranged kind of along the color wheel, right? Red is pretty close to orange, which is pretty close to yellow, and then the more you go in that direction, the closer you get to blue. So in this case, the mode would actually be blue, right? Because there's 2 blue squares, and then median would be yellow because yellow is right in the middle. But mean, if you think about it, is where you mix all of the colors together to form one new color. So it's not any of the colors that are in here, but it's when you mix them all together. That's sort of what mean is, and in this case, right? So that's a little bit of sort of a conceptual way to think about the differences between these kinds of averages. But sorry, Joyce, is your microphone, your microphone's a little bit loud right now. Is it okay if you, all right, thank you. If you have any questions, you can unmute, but like if there's a lot of background noise, I would appreciate it if you mute. That's fine. But anyway, oops. Oh, okay, Did not know that was a feature. Okay, so let's first talk about why you would use each of these. But before we talk about why you would use mean or why you would use median or why you would use mode or why you wouldn't use any of those, let's first do some practice. So let's have a look at these 5 people. 35 kilograms, 45 kilograms, 55 kilograms, 55 kilograms, and 200 kilograms. So does anyone want to give it a shot at finding the mean? So remember, it's adding all of them up, the sum of all of the values, and dividing it by the number of values. So does anyone want to give it a shot as to how we can figure out the mean? I'll give you a moment to think about it. So does anyone have any ideas, or do you want to still kind of keep thinking about it? Like if you have a sort of a framework for how you want to go about this, that's enough, because like adding up all of these is just something you can do in a calculator or you can do in your head. But if you kind of have a framework for how you can figure this out, then yeah, it would be nice if you could blurt it out. Okay, that's fine. I can explain it again. So if we have these 5 values, then we know that the number of values, or the number of people in this case, is going to be 5. So that is what is going to be on the bottom of the fraction, or that's what it's going to be divided by. So on the top, we'll do the same thing again and add all of these values together. So we have 35 plus 45 plus 55 plus 55 plus 200. So I don't know what kind of person will weigh 200 kilograms, but that is going to become important later when we talk about the weaknesses of mean. So if we add all of these together, then we would get, well, what is 35 plus 45? Well, 35 plus 45 is 80. 80 plus 200, 280, 280 plus 55 plus 55. Okay, I'll just use a calculator. This equals 390. And that addition divided by the number of values, which 390 is the sum of all the values, and 5 is the number of values, will net us 78. So the mean weight is actually 78 in this case. So this is kind of weird though, right? Because if I weighed 78 kilograms and I went into this group of people, I would be quite heavy compared to all of these people, right? 78 is quite far away from 35, 45, 55, and 55. But because we have this 200 kilogram person, that 200 kilogram person is going to drag the average up a lot, to the point where the mean is not representative or doesn't really reflect or fit with most of the data. So basically what this means is that the 78 kilograms doesn't really fit with any of this data. And that is the weakness of mean. Mean is easily sort of skewed by these kinds of really big or really small results that make it much farther away from what most of the values actually are. So this is the disadvantage of mean. If we have 200 kilograms, then that means that it'll drag the mean up, right? And it happens because mean includes every single value in its calculation, whereas whereas median only includes the middle one. So the median in this case wouldn't include the 200 kilograms. It would only include the 55 kilograms. It would still be 55 kilograms, which still makes more sense than a 78 kilogram average. So does that make sense to everyone? Why mean can be easily skewed by large or really small results? Okay, so let's move on to another practice with median. Okay, so with median, we want to find the median of these 5 people's weights. And in this case, it's actually very simple, right? You have a 20 kilogram, 30 kilogram, 70 kilogram, and 75, 75, which basically means that if we cross out using that method, cross one from here, cross one from here, cross one from here, cross one from here, we would get 70 kilograms in the middle. So median is pretty simple, relatively simple to do just by hand like this. But if we look at the median as 70 kilograms, that means that this does not really reflect both of these down here. Because the median is 70 kilograms, that means that all of the bottom ones are not represented in this. So median only represents the very middle ones. And it doesn't go to show, it doesn't include those outliers. So sometimes you might want to include the outlier, and use mean, but sometimes if you don't want to include the outliers, then you want to use median. If you want to look at the average person, then you use median. If you want to look at sort of the average weight, combine all of the weights together, and you're basically looking at the average weight or the total amount of per person, then you would use mean. So a good way to think about it is mean is the total amount per person, is the amount per person on average, whereas median is the average person's weight. So here, the median would be 70 kilograms. So does this make sense to everybody? Does anyone want to try doing median themselves? Okay, so let's move on to the weakness of mode. So with mode, it has a very similar weakness to median. So in this case, we have 7 people who weigh 1 kilogram. There's 2 people who weigh 1 kilogram. One person who weighs 100, one person who weighs 102, one person who weighs 103, one person who weighs 104, one person who weighs 106. So basically, we have a bunch of different people with different weights. So most of the people weigh in the around 100 kilograms, a bit more than 100 kilograms. But there are 2 people who weigh 1 kilogram. So does anyone know what the mode is in this case? So remember, the mode is the most common value. So does anyone want to talk about what the most common value or what the mode is here? So Justin says 1 kilogram, which is pretty simple. Yes, it is 1 kilogram. And that is because there are two 1 kilogram people, but there's only one of each of the other people. So mode is relatively simple. It's probably the easiest one to calculate just looking at it. But if the mode here is 1 kilogram, of course, this is not very representative of the rest of the values, right? Because most of the values are around 100, 106 kilograms, but our mode is still 1 kilogram. We cannot say that 1 kilogram is representative of all of these 7 people if only 2 of them actually weigh somewhere even close to 1 kilogram, and most people weigh 100 to 106 kilograms. So in this case, a median or a mean would be much more useful. So this is a sort of introduction to what averages are and what kinds of stuff you can do with them, like why you would use mode, why you would use median, why you would use mean. Why you would use mean. Okay, so let's move on to actually talking about a couple problems. So actually, before we do that, we should practice with a graph, because I know a lot of you are taking the AMC 8 sometime in the future, and the AMC 8 includes a lot of these kinds of weird graphs where you have to figure out the median, mean, mode of this graph. So if we want to figure out, so basically what this is each of these dots represents one person. So let's just say that these numbers on the bottom represent kilograms of weight, so that we can stay with within the kind of similar idea as before. So each of these dots represents one person. So for example, this dot right here that I'm circling represents someone who weighs 65 kilograms. So since there's 2 dots, there are 2 people who weigh 65 kilograms. This dot right here represents someone who weighs 100 kilograms, and you can clearly see that there's only one person who weighs 100 kilograms. So in this case, what do you think is the easiest one to figure out? Mean, median, or mode? Just by looking at the graph. In case you want a reminder, I can also put the definitions in the chat. Yeah, so Justin says that it is mode, and yeah, that makes sense. It's the most common value, and you can clearly see it by looking at which one is the tallest, right? Because there are five people who weigh 80 kilograms, and then all the other weights don't have as many people, right? So this stuff is relatively simple, but if we want to figure out median, then how would we go about figuring out median? So I think we can use a similar sort of crossing out method as before. Just because it's dots now doesn't mean that we can't do that. So does anyone want to give it a shot to find median? So Justin says that it is 82.5. So I think we can confirm that or disprove that by just crossing them out first. So cross out, cross, 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 then boom. So unfortunately, it is not actually the sort of the difference, the middle of the range of them. It is, because remember when we organized it before, we organized it sort of horizontally. We sort of organized it horizontally, right? So it was 62, it would be something like 65, 65, 70. So 70 like that, and then so on and so on until we get to 100. So because there are two 65s, then we would put two 65s. But remember, it's not actually the middle of all of them. Like it's not the middle of the numbers. It's the middle if we arrange them left to right. So I think generally speaking with this kind of thing, like what I find useful is to use the crossout method. Start from here, cross out, and then cross out here, and then cross out here, and just slowly move towards the center, right? So if we slowly move towards the center, then eventually we'll figure out that the median is actually 80, because if we continue crossing that out, then we'll get these two 80. And if we get two if we get two at the end of a median and like there's no one center, then we just keep it as the value of those two, because these two values are 80, and well, the average of 80 and 80 is of course 80. So with median, this kind of graph is a little bit kind of tricks you a bit. So you have to remember that it is not the average of these numbers, it's not the median of these numbers, but the median of the total values which are depicted in the graph. So does that make sense to everybody? Is it a little bit confusing? You want to think about it for a second before we move on? So just a reminder, it is each of these represents a person. So in fact, so each of these dots represents a person. So it is not the median of all these numbers below. So there is another term for sort of the difference between the maximum and minimum, the direct middle, but that is very rarely used. So yeah. But it is also a type of average, though it is very, very rarely used for reasons that like it won't actually depict the center. Okay. So one of the advantages of mean, which as you remember is the sum of the values divided by the number of values. And okay, that tic-tac-toe is actually represents numbers. But basically it means that you can combine the mean of two classes. So for example, here we have a class of 10 students. So there are 10 students with a mean test score of 90%. And there's another class of 10 students that has a mean test score of 92%. So basically what this means is that we have a class of 10 students, and the sum of the values of all of these 10 students equals 90%. And then we have another one, which is the sum divided by 10. It's 10 students. Remember, that's the sum divided by 10. The sum of the 10 students' test scores. Another one, which is 90%. So basically what this question is asking is, if we combine the class of 10 students, if we combine them and put them into a big class of 20 students, then what is the mean test score? What happens when we add all of the 20 student scores and we divide it by 20, which is the number of students in a class that combines both of these, because 10 plus 10 is of course 20. So what do you guys think would happen if we combined both of these? So does anyone want to think about it or point out a thought process for this? It's a pretty hard problem, so, and there are many ways to do it, so I think if you have an idea, you should try it because it's the best way to learn is to try it out, try your ideas. Okay, so the way we need to think about this is, first of all, let's write out what the sum of all of the 20 students would be. So, I mean, sorry, the mean of all of the 20 students would be. It would be the sum of, actually, let's call the first class Class A, and the second class Class B. So the sum of Class A and B. That is the and sign. Okay, there we go. Sum of both Class A and B's scores, all of these 20 students. And then we will divide by 20. And that is what is going to get us what was it called again? That's what's going to get us the mean test score of both classes combined. So does anyone know what the sum of both classes would actually be? Just measuring based on these? Sum of the scores of both classes. Well, we don't actually need to find a numerical number for this. All we need to know is that the sum of the students in Class A and Class B combined in the big class of 20 students is going to be the sum of, or like a sum of all the student scores in Class A plus the sum of all the student scores in Class B. So basically what that means is that, for example, let's say Class A only has 2 students and one person gets 90, they both get 90. Let's just assume that they both get 90, and then Class B has 2 students who both get 92. So they actually have 10, but I don't want to write out 10 values, so we will just pretend that they only have 2 just for this demonstration. So if we think about it, if we add both of these together, we get 180, right? And then if we add both of these together, we will get 184. But if we add both classes together, if we add all 4 of these students together, the 90, the 90, the 92, the 92, then we will get 364, right? But if we add 180 plus 184, we would also get 364, right? Because as you probably learned, the associative property, or basically what it's saying is that it doesn't matter how you order or when you add them together, like eventually it'll all approach the same number. So basically what that means is that the sum of A and B, or the sum of all of the students' scores in Class A and the sum of all the students' scores in Class B, or the sum of the students in Class A and the students in Class B, the combined sum is equal to the sum of the students in Class A plus the sum of the students in Class B. So it's a little bit like confusing with how I'm saying it, because saying the word sum a lot. But basically what this means is that this plus this equals that. So this plus this equals that. And how does that help us in figuring out what this whole value is? Well, if we try to add both of these values together, so we know that it is 90%, we know that this is 92%. If we try to add both of these values together, then we would get the sum of class A, which we can sort of depict down here, and the sum of class B divided by 10, right? Because if we add both of these together, this value and this value together, then adding fractions, if the denominator or the bottom number is the same, then it will stay the same. The new bottom number will stay the same, and only the new numerators or the top numbers will be added together, right? So adding both of these together gets us that, which in the end, if we sort of combine those, we would get sum of A and B. Oh my gosh, can't write an and, okay. Sum of A and B over 10. So let's think about that. So this kind of looks like that, right? The sum of A and B over 10 kind of looks like the sum of A and B over 20. So all we need to do is divide this by 2. But first of all, let's figure out what this number actually equals. Well, it's actually really simple because we already know what the sum of all of the students in class A is, what the average of all the students in class A is, which is 90%, and we already know what it is in class B, which is 92%. So if we do that, then we know that these two added together, this thing, equals 90 plus 92%. And that equals, what does 90 plus 92 equal? 182. So that means that we get that the sum of these two is in fact 182. And since all we need to do is divide these by 2, divide it by 2, so because if we divide it by 2 and divide that entire thing by 2, then it would be divided by 10 divided by 2. And if we divide by 10 and we divide it by 2 again, then it would basically be the same thing as dividing by 20, right? Because, well, think about it. Like, for example, if you divide 8 by 2, then you would get 4. And then if you divide it by again, then you get 2. So that would basically be the same thing as dividing 8 by 4. Dividing 8 by 4, because 8 divided by 4 equals 2, right? So if you divide it twice, then it's basically the same thing as dividing those two numbers that you divided by together and dividing by that once. So in this case, it would be 10 times 2, which would equal 20. So basically what this would mean is that the sum of A and B, or actually I can just write it here. The sum of this would actually equal 182% divided by 2. And what is 182 divided by 2? Well, if we plug that into our calculator, then we would get 91. And clearly we can see that kind of makes sense, right? Because we have these two classes have the same number of students, and well, if they have the same number of students, then we just average them together, and the total average would be 91%. That kind of makes sense, right? But what if the classes don't have an equal number of students, right? What if say slide. What if say one of the classes actually has 20 students and the other class only has 10? Then what happens here? Then what do we do? Give you a moment to think about it, and also to think a little bit about what we did before. Oops. Okay, well, for this one, all we actually have to do here is to say that 90%, let's say that let's say that let's say that we have 10 students, right? So if we have the sum, if we have the sum of 10 students, then sum of class A, which we'll consider this one class A and this one class B, then then A would only comprise a third of the total one, right? And if it only comprises a third of the total, then all we need to do is just say that we will have the sum of class B be represented twice. Or, whoops, that doesn't make sense. Or the sum of class B would be, the average of class B would be represented twice. So before, all we did was just add the two averages together and then divide by 2. But now we have to pretend that, we can kind of just pretend that the class of 20 students is actually made up of 2 classes of 10 students. So what that would mean that, let's say we create a class C out of the original class B. Then we would get sum of A plus sum of B plus sum of C divided by 30, which is the total number of students. So basically what we're saying is that class B, we're going to reduce class B to only have 10 students, and we're going to create a new class that has 10 students as well. This way we can actually average all of them as equals. And basically what this means is that if we sort of split this up like that, then the sum of class A over 20 over 30 over 30 would actually simply just equal, well, before it was A over 10, right? So that would just equal 90% divided by 3, right? Because before it was divided by 10, 90% was divided by 10, and now we're dividing by 3 again, which would equal 30%. But with something like sum B, then we would have the same thing again. Sum B is also 30%. And what that we also get, since we're assuming that B only has 10 students, and the 10 students still have a mean test score of 92, then that means that we would get 92% divided by 3, which equals 30 and 2/3%. And for class C, since it's the same thing, class C will also have a 30 and 2/3%. So this is kind of weird, but you can sort of think about it, instead of thinking about it as splitting class B into 2, you can think about it as giving class B sort of double the strength, giving it double the power. This 92% will have double the power of this 90%. And what we get in the end here is going to be 30% plus 30 over 2/3%, and then plus another 30 and 2/3%. And what we're going to end up with is 30% plus 30 over 2/3 plus 30 over 30 and 2/3. It's going to be, let's see, it's going to be firstly 90 plus 2/3 plus 2/3, which is 4/3. So what we actually get is 91 and 1/3%. One and 1/3%. Yeah. So that's sort of what makes sense, right? Because these 20 students have a higher amount of control over the whole average since they have more students. So that means that it would actually be a bit more than 91% since, well, there are more students with 92%. So this is it's a little bit weird, but basically we're giving different amounts of strength or different amounts of control over the final average to different classes depending on how many students they have. Well, we can also mean in terms of speed, right? So we can do a very similar thing here where we value them differently. But this time, instead of thinking about it as like dividing this up into pieces, we can instead think about 40% only comprises, this 40 miles per hour only comprises 2/5 of the whole. So he drove for 5 hours in total. Drove for 5 hours in total. So 40% will only comprise this 40 miles per hour will only comprise 2/5 of the total amount of driving time. Or instead, you can also think about it as the amount, as instead of the sum in this case would literally just be the amount of miles that she drove, right? And since she drove at 40 miles per hour for 2 hours, well, she drove 80 miles per hour in that case. And if she drove 60 miles per hour for 3 hours, then that would be 60 times 3, which would be 180 miles. And adding these two together, we would get 260 miles. So in total, she drove 260 miles. And we can think of this as the total mean, actually. So if we think of this as the total mean, and she drove 5 miles in total, 5 hours in total, then we would get 260 divided by 5, which is 52. So she drove an average of 52 miles per hour. So that is one way to do it, to directly figure out the total amount of miles that she drove and then divide it by the total amount of hours. So that's how many miles she drove per hour on average. But I think a much easier way to do this is to think about it as the 40 miles per hour only takes up 2, and then just divide that by 5 in the beginning. And then the 60 miles per hour takes up 3, and also divide that by 5. So what we would get is 60 times 3/5. You can think about it as the 40 miles per hour time comprises, well, 2/5 or 40% of the total amount of time, and the 60 comprises 60% of the total amount of time. So if we just add those together, then we would also get 52 miles per hour. If you want to confirm that, you also can. So I'll confirm that right now. And it does indeed equal 52 according to the calculator. So this is basically how you can use mean to figure out the average speed that someone has traveled. And going off of the same idea, since now if I tell you that he drove 260 miles in 5 hours, then I can also figure out the mean speed using the process that I did before, right? Since he drove 260 miles in 5 hours, all we need to do is do this, the 5 hours, the sum. And what we will get is 52 miles per hour again, right? So basically, instead of telling you that the like sort of miles per hour that he was driving, we can just tell you that, well, the total amount of miles and the total amount of hours that he drove. So this is sort of what mean does. It looks at the total and it divides by the amount of hours or the amount of values. This is how you figure out the mean speed. So now we can look at a very interesting way of thinking about this. So we have there are 6 people in a room. 5 of them weigh these weights, but the mean weight is 56 kilograms. So there's one more person that doesn't weigh or could weigh one of these, but there's basically just one more person, and we don't know how much they weigh. So, but we do know the mean weight. So how much does the 6th person weigh? Well, I can give you a moment to think about it first and how we can approach this kind of question. So there are 5 people who weigh this. The mean weight is 56, but there's one more person that we don't know the weight. And the mean weight includes that one last person. Okay, so if we want to approach a problem like this, we need to think about the sum of all of these weights. So the sum of all of these weights, what is the sum of all of these weights, including the 6th one? Well, we can figure that out using the formula. The number sum over number of values equals the mean. And since we know that the mean is 56 kilograms, we can figure this out. And we also know the number of values, which is actually 6, right? Because we know that there are 6 people in total. So now that we have this, all we need to do to figure out the sum is just do a simple algebra, right? Hello? Lloyd, can you hear? Hi. Hi. Ooh. E. Ooh. Ah. E. Ooh. Oh my gosh. Ooh. Ah. Hi. Can you guys hear me? Hello? Okay. Okay. Um, yeah. Okay. So Justin says that he can hear me. Okay. I'll just hope y'all can hear me. But basically in this case, we have the sum, which is we know that sum is going to be 56 kilograms times, well, the number of people in the room, right? Because we wanted to isolate sum, and if you know some like algebra kind of methods of solving these kinds of equations, all you know that you can multiply both sides or do the same operation to both sides, and the equation would still hold. So if you multiply both sides by 6, then this 6 would disappear, right? Because it was dividing by 6, divided by 6, multiplied by 6 is just the same thing as not doing anything at all. So then we would just do 56 kilograms times 6. which would equal 336 kilograms in total. So that is what the sum of all 6 people's weights are, right? So if we know that, then we can do some basic, well, subtraction. So 336 kilograms equals, and let's call the unknown person's weight X. Pretty miscellaneous random variable. And if we do that, we get 35 plus 45 plus 55 plus 80. Oh shoot, I missed the 55. Plus 80 equal, and plus x, which we don't know what x is. This is inequality that holds. So I think the first thing we can do is just add up all of these. 35 plus 45 plus 55 plus 55 plus 80. And if we put that into the calculator, it equals 270. So 270 kilograms plus x equals this 336. And then if we subtract from both sides, subtract 270 from both sides, then we would get x equals 336 minus 270, which would equal 66. So that means that the last person actually weighs 66 kilograms, right? This kind of makes sense, right? You can see that like right now, it's gonna weigh, the average weight is gonna be a bit less than 55 right now. Probably a bit less than 55. Before it was like around 54, right? So we need someone quite heavy in order to balance out the weight and increase it. And if you think about it, you need someone quite heavy precisely because you have 6 people, and you need this person to weigh a lot. So each time one person increases in weight, it doesn't actually increase the total weight by that much. In fact, it only increases it by 1/6. So that means that we actually have to increase it by quite a bit. We have to have someone who's quite a bit heavy in order to increase the weight from 54 point something 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 to 56. So today I covered quite a lot, in terms of averages and just all this stuff. But like, and it is kind of abstract and kind of confusing, right? Like why do you need to know this? But in the end, especially when you get into high school, it's gonna be used in not only gonna be used in classes, of course, and AMC, but also in real life. A lot of times for example, when you want to calculate your grade, which is sort of an average, which is usually made using mean, the average of all of your previous tests, and you want to know how much you need to get on this final test in order to in this test in order to get your grade up, or to get your grade down, or like to prevent your grade from getting down, then you can use this kind of method to calculate exactly what grade you can get, so that you can cheat the system and not do as well on your tests, and try as little as possible to get the best possible grade. And I think that is actually, never mind. That is something you can do, and it is very useful in the real world. Because I do not want to be promoting any bad study behaviors here. Okay, thank you guys so much for coming today. It was a pleasure. So thank you. It's 8:02, so